In this example, we are going to let the probability of C be 0.28, the probability of D be 0.41, and the probability of C given D to be 0.59. In part A, we need to find the probability of C and D. So when we're dealing with finding probabilities of and or statements, and it's not given to us in some kind of table format, then typically we're going to have to use our formulas. Now, I wrote down our formulas for our and the or statements here. There are two formulas for the and statements, and basically it's just rearranging the values of C and D, but they're pretty much the same formula. Whatever value comes first here, whatever event this is, in this case we have the probability of D, and we're trying to find the probability of C and D, then whatever comes first here, you're going to do the other one here, but given that D has already happened, because D is the first one that appears here. So we're going to have the probability of D times the probability of C given that D has happened. And then the same thing over here, we just switch the order of the C and the D. So if C comes first, if we find the probability of C, then we have to find the probability of D given that C has happened. So this is pretty much the same formula. We're just switching the order of the C and the D. So to find the probability of C and D in this first part, notice what we're given. We're given the probability of C, we're given the probability of D, and then we're given the probability of C given D. So using the information that we have, we are going to be required to use this first formula here because we know what the probability of C given D is. So I'm literally going to take the information that was given to me and plug it into this formula to find the probability of C and D. So the probability of C and D, sorry for my messy writing, I'm using my mouse. The probability of D is given to us, and that was 0.41. And now we have to multiply that by the probability of C given D, which was also given to us as 0.59. So to find the probability of C and D happening, we need to find the value of 0.41 times 0.59. And when we multiply that out and round it to 4 places, we're going to get 0.2419. Okay, now the part B says C and D, and then this drop-down menu will say is or is not mutually exclusive because, and then there's an option here to drop down. Now, mutually exclusive means that C and D can't happen together at the same time, meaning if something is mutually exclusive, that means the probability of them happening together at the same time is 0. Because we have a value other than 0 for the probability of C and D, we know that is not mutually exclusive. So I would choose the option here, C and D is not mutually exclusive because, and then I would say, choose the drop-down menu, that the probability of C and D is not equal to 0. Okay, for part C, it says C and D blank independent because blank. Now, you would have something independent if the probability of that event D is equivalent to the probability of D given that something has already happened. If those two are the same, then they're mutually exclusive, meaning it doesn't matter if C has occurred, it's not going to affect the probability of D. These will be the same. We could also write it like this: the probability of C is equal to the probability of C given D has happened. So we're looking to see if these are the same. If these are the same, then it's going to be independent. So if I look at this right here, the probability of C given D has happened, is that the same as the probability of C? Because these are not equivalent, in other words, D is having an effect on the probability of C. If it didn't have an effect on the probability of C, then these would be the same. So we would say that C and D are not independent because the probability of C is not equal to the probability of C given D. They're independent only if these are the same. Okay, part D says find the probability of C or D. So when we find the probability of C or D, we want to use this formula. So we're going to find the probability of D, which that was given to us as 0.41, plus the probability of C, which was also given to us, that's 0.28. And then we're going to subtract the overlap, which is the probability of C and D. And that we calculated in part A to be 0.2419. Now, when we put that in on our calculator and we put that all together, we're going to get 0.4481. So to find the probability of C or D, that's going to be 0.4481 in this case. Now, the last part here, find the probability of D given C. We have this, the probability of C given D, but we don't have the probability of D given C. We can use that formula up here. We have the probability of D given C right here. This is what we're looking for. And we have these other two pieces of information. So we just have to use some very basic algebra to solve this. Now I'm going to erase this so I can have some room. So I know what the probability of C and D is. We found that in part A. So that's 0.2419. And that's going to be equal to the probability of C, which is 0.28, times the probability of D given C. And that's what we're looking for. So when we're looking for something in algebra and we have a formula, if I have 0.28 times some unknown value that I'm looking for is equal to something else, what I'm going to do to find that unknown is just divide both sides by 0.28. So then that way I have 0.28 divided by 0.28. I can cross those off because those, when I divide them, become 1. And I'm left with 1 times the probability of D given C, which is just the probability of D given C. And what I'm left with is just this division problem. So to find the probability of D given C, I need to take 0.2419 and divide by 0.28. When you do that, you're going to get 0.8639.